Hello, this is Mr. Huber. In this lesson, we're going to learn about some special products of multiplying polynomials, in particular, special pairs of binomials, and what we'll see when we multiply them, and look for some patterns within that. So let's start out by finding the product of x plus 4 times x plus 4, right? X plus 4 squared means I'd multiply this by itself. And if they're special products, we'd better get out the special lightsaber to help us out here. So this would be x plus 4 times x plus 4. Okay, don't just distribute the exponent. It's not x squared plus 4 squared. Okay, we can multiply this together, distributing the x into the parentheses, and get x squared plus 4x. And then we can distribute the 4 into the parentheses and get plus 4x and plus 16. So notice if we just distributed the exponent, and got x squared plus 4 squared, we'd be missing this whole middle term here. Right? We have x squared plus 8x plus 16. Right? What you're going to notice is when we square a binomial, so we have a binomial here like x plus 4, and we square it, the first term is whatever this first term is squared, x times itself, right? X times itself would be x squared. The last term is the 4 times itself out here, the 16. And we have these two middle terms which will always be the same, right? It's going to be x times 4 and then 4 times x. So it's going to be these two terms multiplied together and then doubled. So this is a special pattern we should notice. The square of a binomial and the product is called a perfect square trinomial. Okay? This right here is an example of a perfect square trinomial because it's a binomial times itself that gives us that product. So again, you're going to notice, and we have a plus b, whatever they are, whether it's x and a 4 or anything else, right? We take the first term and square it. Same with if it's minus, first term and square it. Then we have the last term squared, so whatever the b is, squared. And in the middle, we're going to multiply these together and double. A times b would be ab, doubled would be 2ab. A times negative b would be negative ab, doubled would be negative 2ab. And we can see what that looks like with some examples here. X plus 5, that's like the one we just did. X squared, 5 squared, and in the middle, x times 5, which is 5x, doubled. Okay? Here, 2x squared. Here, when we have a number in front of the variable, this coefficient needs to be squared as well. So 2x times 2x is 4x squared. Then we'd have 3 times 3. It's a negative times itself, so that's why it comes out positive. It's always a positive on the end here, 9. And then multiply these together. 2x times negative 3 is negative 6x. Doubled would be negative 12x. All right, so we want to recognize these patterns here, not have to write it out the long way every time. So practice that. The more you practice it, the better you'll get at it, the more sense it will make when you need to do it. You can do it more quickly. You can do it without doing those steps and possibly making errors. So when we square 3x plus 8, we're going to take our first term, 3x squared, which is going to be 9x squared. Then at the end, we're going to have 8 times 8, which is 64. Right? So 3x squared is 9x squared. 8 squared is 64. In the middle, we're going to do 3x times 8, which is 24x. Double that is going to be 48x. And that would be our product for 3x plus 8 squared. 4x minus 7 squared. So this is going to be 4x times 4x. Remember, it's 4x in parentheses squared. We're multiplying that all by itself. So that's how we get the 16x squared. The 7 times itself is going to be plus 49, so it's a negative times a negative. In the middle, 4 times 7 is 28. We have a negative because it's 4 times negative 7. So negative 28 doubled is negative 56x. And that's a perfect square trinomial. We multiply a binomial times itself, exactly itself, not something a little different, not close to the same, but the same thing multiplied by itself, same binomial. All right, now let's find the product of x plus 4 and x minus 4. So you notice one's a plus and one's a minus now. So let's write this out the long way, distributing the x into the parentheses. So that's going to equal x squared minus 4x. And then when I distribute the 4 into the parentheses, I'm going to get plus 4x and minus 16. Now you'll notice these two middle terms cancel out. Negative 4x plus 4x is 0x. So we're going to end up with x squared minus 16. This is another special pattern. When it's the same binomial, but we just change the sign in the middle, that's multiplying a sum or a difference. A sum and a difference multiplied together. Okay? It doesn't matter which one is the plus and which one's the minus. So it could be the minus here and then the plus here, but they're different signs, same binomial, The only difference is one's a plus and one's a minus. So sum and difference, we're multiplying them. We get something called a difference of squares, right? This is a difference, subtracting two perfect squares. So the pattern we'll see here is when we have one plus and one minus. It doesn't matter, again, which one's the plus and which one's the minus. We're going to take these first terms times themselves, a times a. We're going to get a squared. B times b and get b squared, except one's a plus and one's a minus, so it's a negative b squared, so minus b squared. So again, over here, x plus 3 and x minus 3. X times x is x squared. 3 times negative 3 is negative 9. The middle terms will cancel out. We want to recognize it, so we don't have to write that out every time. Right? We don't have to write out those middle terms because they're going to cancel every time. It's the same binomial times itself. Let's see some examples of that here. So we have 2y plus 5, 2y minus 5. So when we multiply this, we can just do the 2y times 2y and get 4y squared. And then 5 times negative 5, negative 25, so minus 25. 4y squared minus 25. A difference of squares. The two middle terms in this case would be negative 10y and plus 10y will cancel out. All right, let's do the next one. Negative 4m minus 8, negative 4m plus 8. It doesn't matter there's a negative in front of the 4. All that matters is the same binomial, and these are exactly the same, except for one's a plus and one's a minus. It doesn't matter which one's the plus and which one's the minus. So now we're going to take negative 4m times negative 4m is a positive 16m squared. Negative 8 times 8 is minus 64. Those middle terms will have canceled out, and that's our product when we're multiplying a sum and a difference. So a binomial, that one's a sum, one's a difference, and the two terms are exactly the same except for that sign that's in between them. All right, before we see some more multiplying with special products, a little English invasion musically. Who was the first artist or group to record 20 #1 singles in Billboard Top 100 history? Might be a little tough for you to come. It's been a little while since this group was around. It is a group, I'll give you that hit. Maybe you can come together with somebody and you're probably not going to get it. So just let it be, and let's see what the answer might be here. The Beatles. The Beatles. And those were two of their songs. Come Together and Let It Be are two of their well-known songs. Along with Hey Jude, which was their longest #1 hit at 9 weeks, one of their 20 #1 hit songs, The Beatles. It came from England when they invaded the U.S. Rock scene back in the 1960s. All right, let's move on to some more special products. And you should be trying these. Pause the video and see what answer you get, and then play it and see if what you got is correct. All right, let's work through number 5 here. So this is a sum and difference. The two binomials are the same, except one's a plus and one's a minus. So I have 3x times 3x gives me 9x squared, and then minus 16y squared. If I do negative 4y times positive 4y, that would be my special product for that set of binomials. And now I have 7n plus 10 squared. Okay. Remember, this is one where when it's the same sign, whether they're both pluses or both minuses, I'm going to take the first term, 7n times itself would be 49n squared. At the end, I'm going to have a 10 times 10, which is plus 100. In the middle, 7n times 10 is 70n, and then don't forget to double it, plus 140n. So that would be my product for number 6. Moving on here, number 7. M minus 12r squared. So this is a binomial times itself. So I'm going to start off with m squared, m times itself. And then I'm going to have my last term, the 12r times 12r would be plus, because it's a negative times a negative, 144r squared. When you multiply a variable by itself, where there's a first term, last term, right, you get that variable squared. And then in the middle, multiply those together, I'm going to get negative 12mr doubled is negative 24mr. Okay, and that would be my product there. Now we have a sum and difference, where I'm going to multiply these together, and the middle terms are going to cancel. This is going to be 81, which is 9 times 9, minus 64y squared. 81 minus 64y squared. Again, get used to the patterns here so you're not multiplying it all the way out, finding the middle terms that you don't necessarily have to write out fully. This can be a quicker way, and we're going to see as we go forward, we're going to do something called factoring. It's going to be important to recognize what these products look like so we can get back to where we would have started from them. So really important to practice these and get comfortable with them, even if it seems like it's difficult at first. The more you do it, the easier it's going to come, the more quickly you're going to be able to work through these. So try them using these special patterns and get more comfortable with it as you do. All right, and number 9 here, we're going to have 6w plus 0.5 squared. All right, so in this case, we're going to have 6w times 6w, which would be 36w squared. On the end, we're going to have 0.5 times 0.5, which is 0.5 0.25, so plus 0.25. And in the middle, multiply those together and double it. So 6 times 0.5 is 3. 3 doubled would be 6, so it's going to be plus 6w. And pay attention to that sign in the middle, right? Depending on if you have a binomial that's a plus inside squared or minus, right? That's going to change this sign. Whatever this sign is here, that's going to be the same here. This is always a positive because you're squaring something and multiplying it by itself. But in the middle here, if this was a minus, this would look exactly the same, except this would be a minus 6w in the middle. All right, and now we get one where the middle terms are going to cancel out in number 10. Right? We have a sum and difference, so the same binomials. 12x times 12x is 144x squared. The middle terms are going to cancel. So again, this is one you don't want to have to figure out what's 12x times negative 1/7 and get the middle terms. You don't need to do that. They're going to cancel out. Okay, and now we'd have minus 1/7 times 1/7 is 1/49. We should know how to multiply a fraction times another fraction, multiply the numerators, multiply the denominators, and there's our product for number 10. So recognize the patterns we get here. When we're multiplying a binomial times itself, right, when we're squaring a binomial, or we're multiplying a sum and difference of the binomial. It's the same except for that sign being different. And this one could be the minus and this the plus, and it's still going to cancel out the middle terms. Here we're going to have these two terms multiplied together and then doubled as our middle term. Get comfortable with those. We're going to practice them some more. Special products of binomials, know these two cases and how to work with them.